Greetings and welcome to the YouTube channel. Today we're going to be looking at table schemas in Bigquery. Please like, share, and subscribe. And most importantly, reach out to me in the comments as we give out help, as we receive help on our journey for certifications, whether for its employment or hone our skills. So today let's look at table schemas in Bigquery. So what we want to go about doing is we want to set up our front end right at this link, right? We want to go to downgit and definitely want to refer to downgit as the resource, as definitely a way where you don't want to download the whole repository full of information. You're trying to learn about one thing today, which is table schemas. Definitely want to work with downgit, right? You also want to go ahead, download the Python backend here. Oh, that's interesting. I might not have pushed it. Or I didn't provide a downgit link. Let me go edit that right now. Right? So that'll be taken care of. And now we'll have access to our front end and back end like so. So what we already do is we kind of have everything set up ready to go already, right? The front end is ready to go and the back end is ready to go. If you see from my previous videos, right, you run these two commands, usually npx, and then you run Python tornado server. And before we continue, I just wanted to open up about SAS. So I'm starting to use SAS in 2021. It's been, SAS has been out for a very long time since 2006. It really adds more programming to the CSS. What I don't, well, one particular comment, only thing I don't like about SAS is, well, the nesting, I really don't think that makes sense because there's always going to be a situation where you're going to have to nest very deeply. And when that happens, you're not going to, things get very, very problematic. But my real issue with SAS is the SAS variables. I think SAS variables should be done with, and CSS variables should be used in SAS functions, right? They should compile to the actual value as well as retain the original implementation of CSS values. They should SAS should build on CSS values and add their functionality and features to those CSS values because really it is 2021 and we need our main data types for every programming language out there. Or SAS, right? They add the programming. So consider a programming language, you have the calc and they have operations in there, right? So these data on these pieces of data needs to be bigger. Like in React, right? We don't have HC. Even React does this, right? Even though you understand on this channel, React is very distinct. Even they use Axios, they use fetch over making XML HTTP requests, right? Definitely a more modern data type with less code going into the situation. With Angular, obviously you have your observables in many places, right? And which just allows you to do more, which allows you to wait instead of query whether certain actions have happened on the DOM yet. Saturating needs variables combine those two together, not only JavaScript would have access to the variables, but JavaScript and SAS comes together with their functionality, with two functionalities coming together to create something you've probably never seen before done in the web. So there's my 2 cents on SAS. So SAS, please, if anyone's watching, please. I didn't know they have a getter. I was definitely speaking on this as well. All right, so let us get back to at what's at hand. So let us an overview of table schemas. What we have is how the column definitions of tables are set up. And if you have an example, right, this is if you take a look at the code here, right, we obviously want to set up our environment and like so. But if you take a look at the schema here, as I'm going ahead and copying things, we start to see that, hey, that we have schema fields, right? We have a name, which is like the title name that our column's going to get. And then we're going to see mode later, but then we have the type, and the type is going to be string, right? So this is probably like uh this is probably used for the USPS, right? We're not really downloading anything right now, but that's okay. But we kind of see we're loading our data, right, from a JSON, right, and then we have to specify that in our load job, right, where we're getting our data from, where it's Avro, right, CSV, new line it's really not JSON, so just good to know. New line limited JSON is a good example. So let's go see that play out in the Angular application, right? So the name line table is going to be a key. Right, and now we've loaded 50 rows. But let's head over to the table. Let's refresh like so. Right, they say it's right, and then we want to take a look at our schema. Definitely want to take a look at the preview. Right now, we get to see the row, we get to see the name and the abbreviation. Right, I was thinking post office, but obviously the abbreviation right here, we get to see that name. Right, so when we don't provide a node, it's a mode for our schema field. We get the mode of nullable, and what that means is that it's not required. So if you're adding rows to this table, right, using the SDK or using SQL, right, you don't have to provide a value here if not needed. However, there's another mode that means which value needs to be provided like so, right? But before that, we're going to be looking at we're going to be looking at repeated fields, and repeated fields are like array or like structures, like they're like objects. You read like Java objects, right? In the documentation, they refer to them as structs. Here they're more like objects. So basically, say for example, like didn't you wanted to associate data like the city, the state, the capital, right? You wanted to know the city, you want to know the name of the capital as well as the zip code of the capital. What you end up using, you use the repeated mode, right, to identify as which comes up as a record, right? It's like it's a structs, but really think of them as JavaScript objects in your table, and you're going to see what that looks like. Right? So in this tutorial, right, what we're going to do is we are going to delete the table that already have existed, because when if you're trying to modify table schemas, it's going to be very, very difficult. You're going to be very, very limited in Bigquery. All you want to do is just end up creating a new table. Really, it really won't allow you to do interesting stuff. Right? Let's go ahead and edit the table like so, and let's refresh. Right? And now we want to take a look at the schema as provided here. So we kind of see that we have addresses, we have a type record, and then it's repeated, right? That's its mode, right? Just to represent an object here. And then we see status, address, city, state, and zip. And then if you try to take a preview, all right, table's empty. That's fine. But if we fill this table if you fill this with data, you're going to start to see these values on the same rows. However, they're going to be associated under the addresses tab. Right, so now, say for example, we're loading on data from JSON, right? So for JSON and CSV, right, we could have an auto detect option, which there's a whole documentation about. There's many different rules. We don't want to get into how Bigquery is just going to go about auto detecting the schema. If we provide for that, however, we see in our code, auto detect equals true, which means it'll take that JSON CSV, load about 100 rows, right? That's like generally what it wants to do, and try to figure out the source format, right? So what you can do is, right, I have it here, but let me just clear out my screen here. What we can do is we can use the gsutil command. If you know Linux, just go ahead, use the cat, and then see what's in that JSON, right? So we can see here, we get these are our JSON objects. We get the name and then the postal abbreviation. So since there's not 100 rows, BigQuery could take those 50 so rows and then provide the schemas that it saw, the name, postal abbreviation. Right, and now since the backend is set up, right, we're going to let me make a new table called to leave. right? Because I don't think I forgot to delete this one. And then when it comes to auto detecting too, when it's dates, there's definitely a specific format that you get for date, time, and then time stamps. So really, unless you're using a library to really modify how your date times are going as into exporting, and if you're following on Bigquery standards, right? Um, you're right. It's really safe to just parse out the strings once they come, unless you can't afford, unless you really are constrained in terms of memory or storage or efficiency, right? Um, then would then you could leave it as then you could try to transform your data going in as a timestamp or a date. But really, that's just a lot there too. There could be a whole sorts of issues awaiting you, but it really should be in that format. The only reason I say that there might be issues that await is because um they, there might be characters, right, on the coding letters, UTF-8, ASCII, that, and the third, any little tiny inconsistencies that won't allow you to properly achieve that format, or there might be bugs lying around that won't allow you to achieve that format. So even if the library is really inspecting it, right, it definitely might be an issue. That's why I say just leave it as strings, leave it the way the backend would like it, and if Bigquery wants to store it as a date or a timestamp, fine, let it. It's great if it works. But if Bigquery is talking to your backend and Bigquery doesn't like the value that it sees, I rather try not to force the issue with Bigquery because your backend might do something unexpected, and Bigquery would just go ahead and change it to string again. So even though it's more efficient to try to make sure it's timestamped, do it really only when you need to. And I see more people in this video actually doing it when they need to. But really don't try to force the issue. Just know how Bigquery provides it. All right, and now say for example we want to add a column, and then we're going to talk about things that we're not able to do with table schemas. Right, so we go ahead, add a column. All right, I'm just going to use I'm actually going to use the new table that I made. Right, so this is a code to add a column. We want to see here that we're appending phone with the type string, right? And now a new column's added. So we go ahead and refresh. Good. And now we have the phone. All right, so there is what we can do with table schemas. Now I just want to go over an overview of what we really can't do. We're really not allowed to delete rows. We're not allowed to. I'm not delete rows. I mean delete columns. We're not allowed to take out a table schema. We're not allowed to modify the name of a table schema, and definitely when when it comes to adding a new row, when it comes to adding data and adding new rows at the same time, really, if you really try to do anything special with table schemes, you're going to find yourself doing is you're going to have to find yourself using a destination table, taking that data from the source table, putting it into the destination table. And definitely I'm looking to provide some examples where that will take place in this lab. Other than that, that is the lab today. Thanks for watching. Please like, share, and subscribe. Also, reach out to me in the comments. Reach out to me in the comments. I love to help as well as to receive help. And also another note in the front end, you kind of see that it's very basic. I definitely wanted to provide a way where you could add your own schemas and play with it, but I definitely just wanted to focus on how you do this in Python. Really, the front end is just to make a full stack application. And with AI, it is your challenge, to transform this front end in this particular instance and make it receive any input like so. You want to have a mode. You probably have columns add and remove here, then a mode will pop up, right? Just to ask, say for example, if you get the mode repeated, add like so. I was planning to do that, and I'm probably going to do that in another video, but for this one, definitely want to show you what these schemas look like and how BigQuery schemas are set up, right? So that's just that now. And then a link to the lab will be posted in the video description. Thanks for watching.